Let's talk about virtual memory. Virtual memory is a component of most operating systems, such as Mac OS, Windows, Linux, that we take for granted. It's just there doing its job, running behind the scenes, and we don't pay it any mind. However, if it were gone, we would really miss it. That's because virtual memory has a very important role in the operating system. It allows us to run more applications on the system than we have enough physical memory to support. Let's talk about how virtual memory works. To understand how virtual memory works, let's step back in time and go back into a day before virtual memory. Remember, virtual memory is one of the features provided by the 8386 and later processors. So, if we were going to run Windows, say Windows version 1 or 2, on top of a system that was running, say, a 286 processor, this is how we would have to do things. This box right here represents our physically installed memory in the system. A portion of that memory would be used by our operating system. Back in the days of Windows 1 and 2, that would have been MS-DOS. And then we have a chunk that's being used by our Windows GUI. And the rest we can use for applications. Now let's suppose we have 3 applications that we want to run. Application 1 uses up this much of our installed memory. Application 2 uses this much. Now we've got a third application that we need to run, but the problem is it requires more memory than is currently available in the installed memory banks. It actually needs this much memory, but only this much here is available. In this case, would app number 3 run? Nope. Not enough memory, would not run, no way, not possible. And back in those days, that's just something we figured we had to live with. You know, that you don't have enough memory, you can't run all these applications, right? Well, everything changed with the release of Windows 3.0 and the 8386 processor. These two together could manage our memory in such a way that we could use virtual memory. With virtual memory, we still use our physically installed RAM in our system. We load our operating system into it. We can run applications. We can run app 1 again like we did before. App 2. Remember in our last example, we talked about a third application that needed to run, but there wasn't enough physical memory installed to support the operating system, app 1, app 2, and app 3 all at the same time. With the old model, we couldn't do anything. We could only run app 1 and app 2. App 3 was out of the question. With virtual memory, however, because of the way Windows 3.0 and later was written, and because of the features of the 8386 processor, we can actually map RAM addresses not only to physical RAM, but over here onto our hard drive. What we do is take a chunk of the hard drive, and depending on the operating system, it will either be a file. In the case of Windows XP, it's page file.sys. Under Linux, it actually creates a separate partition that's used only for memory. Either way works just fine. And what happens is that when the system needs more memory, it maps some of its memory addresses out to the hard disk drive. This chunk of RAM right here doesn't actually exist. Instead, it is being redirected to the file on the hard disk drive. And this is very valuable. All of a sudden, we can run app 3 just fine. Because as far as the CPU is concerned, there's extra memory there. But it doesn't really exist. It's actually storage space on the hard drive. This works really nicely. In fact, what we can do with virtual memory is engage in a process called swapping. Therefore, if you're using app 3 actively, you don't want app 3's memory to be stored on the hard drive. You want all of app 3's required memory to be in the physical RAM. Well, what do? Because we don't have room for the operating system and all 3 applications at the same time, what we do is we swap. In other words, we take the application that is currently being used, say app 3, and we load all of it into memory. So instead of being app 1 right here, we'll change this to app 3. Now, App 1, on the other hand, is not currently being used. It's running, it's loaded, but it's not currently being used. Therefore, we will take App 1 and swap it out to virtual memory. It's still there, it's still running, it's still accessible, but because it's not being currently used, we can swap its memory out to the hard disk drive so that App 3 can run much faster. Then, when we need to use App 1 again, and we switch to it, we can take App 3 and put its memory requirements back onto the hard disk drive. And we can bring App 1 out of the paging file over here and load it back into physical RAM. Again, that makes sure that the currently active application is running in physical RAM and not off the hard disk drive. And that allows us to have reasonably good performance. If we didn't have virtual memory, we would have to install a lot more RAM in our systems than we're used to using. If we wanted to be able to run all the applications that we normally do, we'd actually have to have more RAM, considerably more RAM in our systems. We need to be able to run App 2, App 2, and App 3 like we did in that example, all in physical memory. And you'd be surprised as to how much virtual memory your system uses just to do average day-to-day tasks. To illustrate this point, go up to a Windows XP workstation sometime and run multiple applications. Stress the system a little bit. Run 4 or 5 different apps. Then right-click on your taskbar and select Task Manager. Then go to the Performance tab. On the Performance tab are statistics for your physical memory and your virtual memory. Take a look at how much virtual memory is being used in relation to physical memory. You'll be really surprised at how much memory, physical memory especially, is being consumed and how much virtual memory has to be used to keep the system up and running. Now, virtual memory isn't perfect. It works great, but it is possible to overstress the system. It is possible to overuse your virtual memory. And when you do that, the system slows to a crawl. Let's see why. Here we are back with our standard diagram. This is our physically installed RAM. We have our OS running here. And then we start running applications. We run App 1. We run App 2. And these are all capable of running in the physical RAM. Then we also want to run App 3. So we have to start using virtual memory. So far, no problem. Our virtual memory can handle this load. But let's say we load a couple more applications. We load App 4. And then we load App 5, which is a real pig, and it wants to use tons and tons of memory. At this point, we are starting to overtax our virtual memory system. And the problem is not necessarily with the swap file over here, the page file itself, because we can make it huge, right? We have a big hard drive. We can use a lot of space on that hard drive for virtual memory. So it's not the amount of memory itself being swapped out to the hard drive. It's the fact that that swapping has to occur very frequently. If we are constantly moving applications in and out of virtual memory, if we have too many applications going, or the applications we have use way too much memory as opposed to the physical memory installed, then the swapping happens so frequently that the system basically doesn't do anything else. When that happens, we say that the system is undergoing disk thrashing. When a system is experiencing disk thrashing, you know it, because essentially what happens is that the hard disk light stays on all the time because the hard disk is constantly moving information in and out of virtual memory to the physical memory. And when you try to click on anything, like you click on the start button, and instead of popping up immediately, the start button goes up like this, very, very slowly. Because your system can hardly do any work because it's spending all of its time and resources just moving information in and out of the swap file. In the old days, it was very easy to have disk thrashing. Back in the days when we had like 4 megabytes of memory in a system, or if you were really wealthy, you had 8 megabytes of memory in your system, it was very easy to end up in a disk thrashing situation because the size of your physical RAM was so small. Today, disk thrashing happens less often, but it still can, especially if you're using a very memory-hungry application. In that case, I just had this happen to me a couple days ago where I was using a system that had a full gig of memory. It was on a 2.5 gigahertz Pentium 4 system, and I still ended up in a disk thrashing situation because I was running an application that required huge amounts of memory. One application itself required 512 megs of RAM. I had several other applications running, consuming the rest. And I took a look at my performance statistics in Task Manager, and I saw that almost all of my physical memory was consumed. There was very little physical memory left. My page file was being consumed at an alarming rate, and my hard drive was spinning constantly, moving information in and out of physical memory. So what do you do if you're having a problem with disk thrashing? There's really only two resolutions. One, quit running so dang many applications, or two, install more physical memory in the system. Either one of those will fix the problem. In this lesson, we talked about virtual memory. We talked about the difference between physical memory and virtual memory, and then we talked about how virtual memory works.